Hey guys, this is Joshua, and today I'm going to be showing you how I can route a BGA with bypassing and on a 4-layer board PCB. So let's get started. So the processor we're going to be using is an ATSAM32, I believe. Yeah, ATSAM32. And it is a 32-bit processor, and it's the same processor used in the Arduino Duet, but this is actually using the BGA version. Yeah, and this is just straight from the reference schematic where we have our ferrite beads for each of the power, and we have a lot of bypass capacitors. So let's just get started. So I'm gonna start this completely fresh so you get an idea of how we do this. So we're gonna convert schematic to PCB. I'm gonna go ahead and make this 4 layers. And bam, all right. So the first thing I like to do is I like to hide the layer. So the document layer is probably unnecessary right now. Okay. And then I like to change some of the colors because the colors right now, they look kind of gross. So we're gonna have a top and bottom layer. That will be our 2 signal layer. And then we're gonna have a power layer. And then we're gonna have a ground layer. Okay, this should be good, but I'm actually gonna make this signal for now just because I'm not used to making that plain. Okay, so this should be fine now. All right, so we're gonna move some of these stuff to the side that are not really critical. We're gonna start off with the bypassing capacitors. So that is basically all these. You can have this loaded on a separate window. I'm just gonna go ahead and take a screenshot over here and put this off to, actually I should probably take a screenshot of this bottom side as well. And then that way I'm familiar with all the numbers of capacitors. So let's start off with C22 right here. And we're just gonna I'm gonna go ahead and delete all the labels because they're in the way. All right, so we're just gonna go ahead and put all the capacitors that are the same category for bypassing close together. This is C14. So these are all the capacitors for the 3.5 volts. Now I think I'm just gonna go ahead and put all these as close as I can. So we have a lot of capacitors. So this is for VDD out, so we're going to put that on a separate section here. And there's another capacitor for VDD out, that is C34. And this is VDD analog, so this is where the analog voltage is. So we need to be careful when routing that to make sure it doesn't get close to digital pins. Okay, and then the rest of the capacitors. So I covered all these here on the top. The rest are these over here. So we're gonna go ahead and do that real quick. C6. So yeah, this is what I like to do in the beginning. Is since the bypass capacitors are the most important, I like to get these out of the way. Then the next thing I would do is probably the oscillators and any of the critical signal traces. And then finally the rest of the trace. So we're gonna get these out of the way first. And the capacitors will also define our power plane, how we want to split it too, which is probably the most important step. So before we do anything else. C11, almost done here. C12. and then C32. Okay. So I'm going to go ahead and go back to schematic. And let's see here. We can ignore the oscillator part. We have two more capacitors, C25 and C21, and then C27. This is for the LDO, so we're going to ignore that part for now. And I don't think we have any. We have capacitors for these. We'll just add them later on. They're not bypass capacitors. Okay, so then C25 and C21 are our last two that we need to add to the chip. C25, and then where would C21 be? All right, so this is good. Okay, so how do we actually put the bypass capacitors close to the pin? Because if we're doing a board like this, you know, what you could do is if you're only limited to 2 layers, your only real option is just to try to put these as close as possible and then try to do fan out with them with vias and stuff. But because we have 4 layers, we can make a power plane. So we're going to go ahead and do that. So we're going to take a look at this chip, and we're going to go ahead and start putting the bypass capacitors. And the way I like to do it on a BGA, and really the only way to get it right up on the pin, is to do it on the bottom layer. So we're going to change all these to the bottom layer. Okay. So let's get started here. So this is VDD analog. And all these sections are analog, so we need to make sure we have good separation between digital and analog when we're routing. So that's just something to note. We're going to go ahead and start off with these 2 capacitors over here and rotate them. Okay. The other thing that I forgot to do is to set the design rule. So we're in millimeters for some reason. Let's go to mils. So I like to keep my trace width a minimum of 4 mils and 4 mil clearance. A via diameter of 8 should be sufficient, and a via of diameter of 10. Okay, so let's create a via here. Let's go ahead and follow those rules. This is a bit small, so if you're a PCB manufacturer, most PCB manufacturers will probably not be able to make this. So you might have to find PCB manufacturers specific for this case scenario. Snap size is how large you want the grids to be when you're moving the components. Right now it's 5 mil, that's way too big. So then go with 1 mil, and the AW is 0.5. So I can move this much more precisely, and when I press AW, it's even better. So we're gonna start off we can start off with the ground actually before we do this. So my bad here. Should have planned this earlier. Should have planned this beforehand. So we're just gonna go ahead and copy that and put it near all the grounds. And since we're gonna have a separate ground plane, we really don't need to worry much about the fact that we're gonna have capacitors underneath it. And that's really why, if you're gonna be doing this kind of BGA, you could do it on 2 layer. It's just going to be much easier if you can get it to 3 layers. I mean 4 layers. And like also you're going to have better bypassing with 4 layers because you can put the capacitor actually on the pin versus on the sides. I did make a board with this chip on a 2 layer and it works, but I really would suggest doing it on 4 layers if you're going to be doing BGA. At least 4 layers. And usually 6 layers would be better, but that's usually pretty expensive. Okay, so we fixed I think we placed all the ground vias, and now we're gonna go ahead and start with the VDD analog. So type in VDD and for the nets and put this over here. And now we just route a trace like this. So the thickness of the trace, 10 is a little bit thick for this. I usually like to keep the trace width. I read somewhere that the trace width has to be exactly the size of the hole, and that just makes sense to me, so that's the guideline I follow. I could be wrong, so if I am wrong, you are free to correct me in the comments. Okay. and we want to keep these as close as possible. So like that. And the good thing is, since we're gonna have a power plane, oh, I moved the mic, my bad. The good thing is, since we're gonna have a power plane, we don't really need to worry about putting the supplying power to the capacitors. It'll just be supplied from the power plane. All right, I'm gonna get all these grounds out of the way, just because they're bothering me. Perfect, and right here. And then right here. All right, now let's do VDD out because there's a lot. So the basic rule of thumb is we want to try to keep one capacitor, one 100 nanofarad capacitor on each power pin if possible. But you'll notice that some of these have two capacitors. So on VDD out, there is a 22 microfarad and also 100 nanofarads. In that case, these are technically supposed to be close to each other because the way that bypassing works is if you have multiple capacitors, you're essentially lowering the impedance on a wider frequency range than if you only have one, if you have multiple different value capacitors. So that's really the goal with that. And when we're designing this, we have to then look at how we can put those two close together. So if that's for VDD out, then let's see here, where's VDD out? Oh, that's for VDD out M1. So that's not for this, I don't think. Okay, that's not for this. Yeah, I got a little confused. VDD out is all 100 nanofarads. There is 122 microfarad, so we might want to put that. I would suggest putting that as close to where VDD out is, like on the average pins of VDD out, and you know they're all here, so we can just put that there. Okay, good. All right, so let's start with that then. We're gonna find our 22 microfarads in this range. I think the 22 one is C32, so I'm just gonna do a search. Okay, so this I would probably put here. And then all these are just 100 nanofarads. I don't think I'm going to have enough space because I also have this 3.3 volts. So we're just gonna have to do our best to put this like as close as I can. Okay. Ooh. Oh yeah, that's probably important. Let's lock this so it doesn't move. And then let's get our last VDD out here. Okay, so we have 3 100 nanofarads. Those are for the individual pins. And then we have one that's a 22 microfarad to, like I said, widen the range of inductance that we're lowering in terms of frequency. So let's go ahead and just route these here. And then we might have to move this later because this is going over a lot of different, I don't know if we're gonna have enough signal paths, but yeah, we might have to move this there. And I'm just gonna route it like that. And then ground, I'm gonna go ahead and pour the ground layer on the bottom layer so we don't need to worry about ground for now. Okay. Oh, there's another VDD out over here. Okay, so I guess that's what this would be for. The VDD out over here is there's another one here. Oh wow, there's a lot. Okay, so the VDD out here is pretty close to the edge, so I might just be able to put this on the bottom layer on the top layer, but I'm gonna keep it at the bottom layer for now. And then if I don't have enough space, then I'll put it on the bottom layer. Okay, and then this one, I'll just put over here. All right, we are looking good so far. So now we are going to go ahead and copy these vias and go ahead and finish this up. All right, I'm gonna go ahead and try to move these as close as I can. This is over some pins, and if you're gonna be using those, you might wanna, well, this is on the edge, so you don't even need to do fan out for those, so that should be fine. I could put this capacitor on the front, but like I said, I suggest just putting all the bypass at the bottom, so you have sufficient space for your signal routing on the top layer. Okay, so we are done with that part. And now we can move on to the real hard stuff, which is 3.3 volts, because we have a lot of that. So I'm going to go ahead and copy this via, change the net to plus 3.3V. Okay, we are good to go. So we have one pin over here. Let's do a scan around. I'm gonna go to the front. Okay, I'm gonna hide some of this stuff. We don't really need to see the silk screen right now, so I'm just gonna hide that. Let's see if we have any 3.3 other 3.3 volts. One right here and one right here. Hopefully that's it. Yeah, I think that might be it. If I miss anything, I'll notice it later. Okay, and then let's go ahead and just finish the fan out part for the 3.3 volts. Oh, there's one more over here, of course. Oh, this is VDD out. Oops. Why is it showing the red? Oh, there's probably a component underneath it. Okay. All right, so that becomes a challenge. I'm probably gonna have to move this a little bit to the right for space reasons, and then that's when I need the silk screen layer. Okay, I'm just gonna have to move this to the side for now, and then put these back because I don't want to put the bypass too far away. And let's just go ahead and rotate this. So sometimes you do, unfortunately, have to make sacrifices with how you want to lay out your board, just because space constraints, and you're not really going to ever be able to make it perfect. So yeah, that kind of sucks. Anyways, this is a 22 microfarad, so I probably won't put that there for now. Let's do the 100 nanofarads first. Okay. And then over here. That should be good. So these aren't like close to the ground, but we should be chilling because we're gonna have a very big ground plane and we're gonna flood the ground on the top. Right, I'm just gonna rearrange this so it's a bit nicer. Okay. And then we can go ahead and do our work here. Perfect. And then we have one more 3.3 volts over there. And I might be able to just put this over here so it looks very nice. What the heck happened here? So it looks very nice and clean. All right, perfect. So there you go. So that is, I believe, oh, there's one more over here. So let's finish that up real quick. I believe all the power and ground sorted out. Okay, and then these are extra capacitors that we'll deal with later. Okay, so then we have one more voltage. I think we have VDD PL. Okay, so let's finish that. What is this connected to? Oh, that's just the ferrite bead. Okay, so we're gonna go ahead and copy this via VDD PL. I mean PLL. Oh, and then we also have VDD out that we have to finish. So let's just do the VO first here. Do I see any more? Okay, this is really in the way. Okay. Okay. I think we only have one. And that would actually make sense, so. Okay. And then we have VDD out here. All right, and then I'm just going to go ahead and put these together. And we are chilling here, so let's go ahead and put the capacitors for those, which is a mess right now. Okay, so this is a bit tight in space, but I might be able to do it like this. I do have a reset here, which I know I'm going to need. All right, these digital pins are probably not as critical as the reset, so I'm gonna put this up here. The digital pins I can just route from the top. The reason why I need to put that up there is we have VDD out me here. And I have two capacitors that's needed for this. I assume these are different values, right? Yeah, 100 nanofarads. And so I like to put the 100 nanofarads just close to the pin just to keep it standard. And I think I read somewhere a while ago that that's what you should do. So correct me if I'm wrong. All right. That's all the bypass that I'm aware of, unless if I miss any pins. Okay. Now with the bypass done, what we can really start doing is looking at our power plane and how we want to split it. So this is our analog power. We're going to ignore that for now. This is a 3.3 volt line. 3.3 volt is probably going to be our biggest plane. We also have VDD out. Let's just start with VDD out. Is that a good place to start? I think that's a good place to start. Okay, so we're going to go ahead and make the net VDD out. And let's just start with that. So nothing here is using power. So I can probably just make this really, really big. So we do have a 3.3 volt, so I'm going to have to cut it here. Okay, I might have to readjust this later. Most likely I will have to do that. Okay. Now I like to change some of the settings. 10 mil is a little too much for me, so I like to make the clearance like 6 mil. And then I also like, for power planes, we want it direct, not spoke. So although we're not doing anything that would require spoke, so I don't think it would just, it wouldn't generate that automatically, but just to be in the safe. Okay, so that's our power plane. That's a very yucky color, so let me just change that to something a little bit more traditional, like maybe purple or something. Okay. All right, and then let me change the, I don't like the green for ground. I like something like, probably something light blue. All right. Let's make this a little different color. This is very critical right now. This is way more important than the routing part. Okay, so now, all right, that's easier, just easier on the eyes. Okay, so that's our VDD out plane, and we'll adjust it accordingly. Now let's do 3.3 volts. Fridge. Okay, so we have a 3.3 volt pin here on the top. We could just do that last, actually, because I can make the whole thing 3.3 volts, which is probably really what I'll need to do anyways, because there's going to be too many to. So we're going to start off with something like VDD out me or something, which there's only one of them, so. Huh, okay. That is very fascinating, isn't it? I'm trying to think here. I could probably just put this here for now. And then I'll just adjust it later, really. Where's my, I can barely see the cursor. Okay. All right, and then of course, 6 mils, and then direct. Not like that does anything, because we're not doing anything spoke. All right, and then VDD fill would just have to go to the bottom here, I think. Oh, I just realized we have another VDD out here. Okay, that's fun. I can just make another layer here. I can probably do it like this. Okay, let's figure out VDD fill first. So I really want to put all this near the corners. Also, when you're doing power playing, you should try to keep a decent clearance between the I really can't see the cursor, so I'm just guessing here. Okay, so I don't know if we have enough clearance to be able to fit on. Let's turn this off for a second. Where is my layer? All right, there it is. Is this it? Oh. All right, let's try 6 here. Okay, that is very thin. What I could do is I can move this just up a little bit. Am I touching anything? Why is it showing red? Oh, it's just the layers. Okay, so I could do that. I don't think this is any high current application, so it's probably not a big deal. But I still want a pretty good ground. I could be pretty good power plane. What is happening over here? Okay. I could also make this plane a little bit smaller on the just on the corner, because there's only one via here, so I could just do that, and then that way the other one can just be bigger. Which it's not, but I think that's because I outlined it that way. This is way too hard to see. Yeah, maybe there's a reason why they didn't go with this color. What in the world? I can't click on it. What the fuck? Dude. Okay. Wow, that is horrible. All right. I'm just gonna make this wide. I already have the clearance set anyways. You don't want to put your power planes too close together. And that's really just because it's hard to manufacture them when they're close together. But since I have the clearance set, I can put this as close as I want, and it still wouldn't be touching. It still wouldn't be really close. It'll still follow my clearance rules. Okay. So that's good, I think. Let's continue here. So we do have a VDD out pin here at the bottom. And that's a bit annoying because we also have a 3.3 volt pin here. So what I'm going to do is let's figure that out first, the VDD out, because I want to do the 3.3 volt last, and you'll see why in a moment. I'm just going to have to do it like this then. Where they made this way too thin. Okay. So now that's connected with everything except the 3.3 volts. Dude, I can't click on this. This is ridiculous. What the heck? All right. Oh my gosh. Okay. 6 mil and then direct. Okay, I don't know if I like this, because this is pretty thin here on the edge. I think I might just go ahead and do this. Make it just a tad bit thicker here on the edge. And I also don't like really sharp angles like that. Okay, that might be a bit better. We'll see. All right, and then we have our analog, and analog is the one that we have to be careful of. So we will go ahead. I'm just gonna have to change the color. I didn't know I used that color before. Let's just go with something like light green or something. Okay. All right, and then let's go ahead and route the analog. And really, this one is super straightforward because we're right here on the corner, and they probably did that on purpose because they know you should have separation. So we're just gonna route it here for now. And we can readjust it later as we need to. Okay. So I think this is a good place to pause, but before I do that, I will just do the 3.3 volt to see how that is. And we will continue in a later video with a part 2. Okay, so this is the 3.3 volts. And of course, I need to make the clearance 6 mil. And yeah, okay. So this is the 3.3 volt plane. And this is really how everything is split up. Now, we could do it. You could make the whole thing 3.3, but for now, we don't know the other voltages of devices we're using. So I'm just going to go ahead and make a separate layer for the 3.3 volts. And just outline the edge like this. So unfortunately, this is quite a complex shape. Just do like a rough outline, really. All right, so let's add 3.3 volts. And then 6 mil here. Yeah, so we're gonna, most likely the whole board would be 3.3 volts, but we're really just going to separate it we're just gonna keep it within the boundaries for now. All right, so yeah, so let's do a recap of what we've done here. So we added all the VS for each individual power pin. We added the proper bypass capacitors as close to the pin as possible using proper techniques. And we've added all the sufficient power lines. So in the next video, we will go ahead and start placing some of the critical components like oscillators, and then also like figuring this all this stuff, what we can do with these, what we're supposed to do with these extra capacitors on the sides. All right, thank you so much for watching. I hope you found this tutorial helpful, and I'll see you next time.